My name is Munyaradzi and I'm going to be presenting my thesis that is titled Evaluation of a Mechanized Cut to Length Harvesting System in Different Geometric Thinning Operations in Terms of Productivity, Cost, Biomass, Conversion, Residual Stand Damage, and Spacing Uniformity. So the presentation will start with background, followed by methodology, results, and then we'll end with a conclusion.
Yes, let's see this C29, the first issue.
I think there's some background somewhere, Simon. Okay, thank you. So thinning is a silvicultural prescription that is aimed at reducing density and improving stand quality and stand health, and thinning also stimulates the growth of the remaining trees. However, the challenge with this very important operation is low removals, high operational costs, small tree sizes, and mainly stand irregularities. Hence, this study investigated alternative thinning methods to potentially improve productivity, reduce harvesting costs, but mainly to try and improve thinning quality. So the research questions that were asked in this study is that will a change in thinning geometry improve spacing uniformity and site utilization? Will it improve the cut to length harvesting system productivity? And will it introduce any other practical challenges? So coming to the methodology, this study was conducted at York Timbers at the Jezebel plantation in the Mpumalanga province in South Africa. And this figure here on the right-hand side shows the study, the exact location of the study site and the two stands that were used. So I'll go through the methodology and I'll try to connect the activities that we conducted and try and connect it with also the methodology to be one thing. So the first three things that we did was to firstly identify a suitable stand, set up experimental plots, and then do enumerations. So two compartments or stands were identified, which was P19 and P20. And they were adjacent to each other. The two compartments were then divided into different blocks, as you can see, from block 1 to block 12. And then experimental plots were then instituted inside those different blocks. The two thinning treatments that were tested in this study is the conventional 7th row thinning method and diagonal thinning. And these two treatments were alternatingly placed into these blocks. Then the width of our strip rows was determined by our highest boom reach, which then is what determined us removing the 7th row on the first treatment, and on diagonal thinning, we were removing the 9th row. After putting in our experimental plots, we then went in and did our enumerations. We measured our diameter at breast height using a diameter tape. We measured our heights using a vertex. And then all the trees that were in the experimental plots were then assigned with a unique number for easy identification and merging of data later on. Then this is the stand information for the two stands that were used. Both were of the Pinus spatula species. P19 was 34.65 hectares big, and P20 25.15 hectares. Both were on a 3x3 planting geometry, and both were 8.4 years old. Then after we then did our UAV flights pre-thinning, where we flew using drones, where we flew the two stands. This is P19 and P20 before before we started harvesting, and I'll explain later on the reason why we conducted these, why we did these flights. Then we started our harvesting, where we did our harvesting time studies. The system that we used here was the cut to length harvesting system, where we used a Ponce beaver. harvester, which we use for felling, debranching, and cross-cutting. And for forwarding, we used a hybrid tractor forwarder. The reason why we chose to use a hybrid tractor forwarder was because of the limitations in our strip, in the width of our strip rows, especially diagonal thinning, which only accumulated to about 3 meters. So most of the conventional forwarders wouldn't be able to fit without causing any sizable damages. This hybrid tractor forwarder has got a width of 1.9 meters over tires, which perfectly suited us, and it was also readily available for the study. So for the time studies for the harvest, these are the elements that we used for timing the harvesting, which we started from traveling up to processing. And these are the time elements that we used for the hybrid tractor forwarder, starting from travel unloaded on the forest road up to unloading at landing. Then we did residual tree damage assessments. And this was done in 3 phases. Firstly, we tried to we assessed our residual tree damages by looking at the location in the stand away from the strip row where the damage occurred, whether it was on the first row, second row, or third row. Then we also assessed where the damage occurred, whether it was on the root collar or up to 2 meters or above 2 meters. Then lastly, we also checked the size of the wounds. And then we categorized them according to light damages, moderate damages, and severe damages. Then after the time studies and the damage assessments, we then did our UAV flights again, post-thinning. As you can see here, this is an example of P20 before thinning and after thinning. We then assigned circular plots, and this was mainly done for us to be able to measure stand uniformity, the impacts of changing a thinning geometry on stand uniformity. And then we used RStudio to try and get our tree points, and then from that we then used QGIS to try and get Verneuil polygons that we then used to check the space that was around each individual tree. This is an example of before thinning for the conventional 7th row thinning and after thinning, and this is an example for diagonal thinning. Then we also did costing, and this was done using the cost action costing model, and we looked mainly at fixed costs, variable costs, and operator costs for us to be able to determine the cost of harvesting and forwarding and for the total system. Then we also did waste assessments where we went into our strip rows and we put in some subplots, and we tried to measure any woody biomass that has got commercial diameter. We also tried to categorize our waste, for example, according to what was the cause for the damage. For example, here, this was categorized as machine damage. This was categorized as trimming, whereby the logs had the length was there, but then for us to be able to take out our product, which is 2.4, we didn't have the commercial diameter, which is 8. It fell into 7 or 6. Another example is here, whereby we also measured the offcuts, and we also measured any woody biomass that could have been caused by the operator trying to solve quality issues on trees like fork, sweep, and corkscrew. Then lastly, we did harvesting simulations using a harvesting simulator developed by Ackerman 2016, and we we tried to use this simulator to see the impacts of planting geometries and thinning intensities on productivity. Then data analysis was done in RStudio, and then we go to the results. So firstly, on the time study results, there was a significant difference between the two treatments in terms of time consumption, with diagonal thinning causing most of having the highest time consumption during harvesting. In terms of time consumption per element, the time consumption, the proportions of time consumption was consistent between the two thinning treatments, with processing being the highest consumer of time and boom in being the lowest. Then this is just a summary of our time studies. All the elements, there was a significant difference between the two treatments besides boom in, and this could have been caused by the harvester length, because both treatments, the harvester boom reach, because both treatments had the same harvester boom reach. Then for us to determine our productivity, first of all, we compared our plots in P19 and P20 for any significant differences in average tree volumes. We also compared the different blocks for significant differences in average tree volumes. And we also compared our thinning treatments. And then after that, we had to exclude block 7 and block 9 as they were causing significant differences. This is a summary of the results from each block per treatment. And in overall, there was a significant difference between the two treatments, with the conventional 7th row thinning method having the highest productivity of 16.4 cubes per productive machine hour, compared to diagonal thinning that had a productivity of 14.3. We also try to model our harvester productivity using multiple linear regressions. And these are the variables that we first tested, and then the final model only had thinning method and stem volume at an R squared of 84%. And this was the final model that we developed using also dummy variables. And this figure here then shows us the relationship between our productivity and the stem volume. We then also looked at the results of our hybrid tractor forwarder, and this is just a summary of the different elements comparing the two treatments. This is also a summary of the productivity for the hybrid tractor forwarder according to the thinning treatment and according to the different blocks. And consistently, we can see that the blocks in the conventional 7th row thinning method had higher productivity than those in diagonal thinning. The final productivity for forwarding was 5.36 for the conventional 7th row thinning method and 4.61 for diagonal thinning, which was quite low. We also then did model our productivity for this hybrid tractor forwarder using these variables you see here. And the variables that were in the final model was distance and the volume per 100 meter, with an R squared of 55%. And this is the final model, also using dummy variables. Then looking at the final costs, this is the cost for the harvester and the cost for the forwarder, and also the total cost for the system. The conventional 7th row thinning method had the lowest cost at 273.93 Rand per cubic meter, compared to 324 Rand 0.28 for diagonal thinning. And mainly the high costs were mainly caused by the low productivity in the hybrid tractor forwarder. Then also looking at some of the results from the simulations, we did find that planting geometry, on all the planting geometries that we tested, planting geometry did have a significant influence on productivity, and also thinning method, and this is consistent with the result that we also got from the time studies. And then the rest of the variables like thinning intensity did not have any significant difference on productivity. And this is just a snapshot of visualization of an output from the harvesting simulator. And this is an example of diagonal thinning just before the thinning and afterwards. And then this one is for the conventional 7th row thinning method. Then in terms of damages, there was a significant difference between the two treatments in terms of severity of damage, and in terms of, in overall, there was also a significant difference between the two treatments. For diagonal thinning, the harvester caused most of the damages at 14.35%, and the forwarder caused lesser damages. And for the conventional 7th row thinning method, the forwarder had the highest, caused the highest damages at 4.9% compared to the harvester. In overall, diagonal thinning had an damage intensity of 8.9% compared to only 4.4% for the conventional 7th row thinning method. Then in terms of our waste assessments and our fiber losses, there was again a significant difference between the two treatments, with the conventional 7th row thinning method having a waste of 12.65 cubes per hectare compared to, with the conventional 7th row thinning method having a waste of 10.52 cubic meters per hectare compared to the diagonal thinning that at 12.65 per hectare. As you can see here, most of the waste was caused by trimming, which caused about 57.5%, and this was also consistent even with the diagonal thinning. And off-cuts had the lowest contribution of only 0.9 for the conventional 7th row thinning method, and also consistent with diagonal thinning. Then coming to thinning quality, we also looked at volume distributions before thinning and after thinning, and we also here in black is what is the volumes that were removed. As you can see from these two figures here, which is a histogram, this is for diagonal thinning and this is for the conventional 7th row thinning. Diagonal thinning did quite a good job with removing this small sized trees, and after thinning with pushing the volume distribution slightly to the right, compared to the conventional 7th row thinning that maintained a normal distribution before thinning, after thinning, and the removed. Meaning that the selective thinning component of it was quite less. And then this is some of the results of our volume distributions. And as you can see, for the diagonal thinning managed to remove 64.6% of all the small sized trees that were measured in our experimental plots, compared to only 38.8 for the conventional 7th row. And it removed only 10% of the large sized trees that would want to retain, compared to 20.8% for the conventional 7th row thinning. And then looking at spacing uniformity, both treatments had a normal distribution of spacing per tree before thinning, and this slightly moved to the right after thinning. But mainly, as you can see here, before thinning for the conventional 7th row thinning, most of the trees had a spacing of 8.7 to about 11.7 square meters. And this was also the same for diagonal thinning. But however, this shifted after thinning. For the conventional 7th row thinning, it maintained that spacing of 8.7 and mostly up to 11.7. And for the diagonal thinning, it then became 5.7 to 8.7. And this could have been caused by the differences in our strip, in the width of our strip rows. Then we also looked at Clark and Evans aggregation index from our simulations, and this index helps us to see, to look at spacing uniformity. If there's an index, if the index is more closer to 2.1, it shows that there's uniformity, and then if it is less than 1, then it shows irregular spacing. So as you can see, before thinning, all the indices were close to 2.1, which shows that there was uniformity for both treatments before thinning. But after thinning, then diagonal thinning had the highest index of 1.3 at 35% thinning intensity, only compared to the conventional 7th row that also at 35% intensity for the 3.3 meter planting geometry had 1.2, which shows that as intensity increases, our uniformity also increases, but it becomes much better with diagonal thinning because it had a higher selective thinning degree. Then looking also at the degree of selective thinning, which we also did using the simulations. At 35% thinning intensity for the 3.3 meter planting geometry, diagonal thinning had a selective thinning degree of 68%, which was the highest, compared to only 60% for the conventional 7th row thinning method. And then looking at all of them, we found that diagonal thinning improved the degree of selective thinning by an average of 8%. Then in conclusion, the study successfully showed that the conventional 7th row thinning method was superior in terms of productivity, costs, and residual stand damages. However, it is very important for us to note that first thinnings is a silvicultural prescription or operation. Hence, it's very important for us to measure the outputs of our first thinning more based on the basic principles of thinning, which is for us to reallocate spacing, to reduce density, and to improve our stand health through more selective thinning and removing suppressed trees. So diagonal thinning did show that it was much better in terms of improving spacing uniformity. It was much better in terms of improving selective thinning. And it was much better in terms of the size or tree size distributions after thinning. The recommendations is that further studies could investigate the impacts of changing thinning geometry on the final crop in terms of growth and tree quality. Also, we could look at different harvesting systems in terms of productivity and residual tree damages and costs. And lastly, further studies could investigate the cut-to-length harvesting system in terms of productivity, cost, and residual stand damages in second thinning. Thank you. This is the end of the presentation, and I would like to thank our funders, which is FSA and the DST Sector Innovation Fund. I would also like to thank York Timbers for giving us the resources and the study site for us to conduct this research study. And I would also like to thank my supervisors, Prof. Bruce Talbot and Mr. Simon Ackerman. Thank you.